Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of slope as unit rate. This is standard 8.4b in the great state of Texas, and we are using item number 4 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So a water hose discharges water at a rate of 45 gallons per minute. And this per lets us know what our rate is going to be. Whatever comes before is usually going to be on top of our fraction, so our numerator. So this is going to be gallons. Make it a fraction, and it's per minute. And they don't give us a number, so we can infer that it's 1 minute. And so it's 45 over 1. If you wanted just to do it as a whole number, you could do 45. You could do gallons per minute if you want to. Sometimes you might even do 45 GPM, kind of abbreviate the gallons, the per, and the minute. But either way, we want to graph this. We need to find a slope that matches this unit rate of 45 gallons per minute. Well, when we are looking at slope, this is what we need to remember. Our slope is this is where it gets slightly tricky, change in y over change in x. So that's a little saying we have is rise over run. So really, we're just taking two y coordinates, subtracting them. That's our numerator. We're taking two x coordinates, subtracting them. Obviously, the x and the y coordinates need to match up. That's our denominator. So this 45 over 1, but even though when we go to our coordinate plane, typically we're always going to write our x coordinate first. When we are graphing it as a unit rate, the y coordinate is on the top. That's our numerator. The x coordinate is our run. That is our denominator. So let's take a look at the slopes here. Let's start with f, and I'm just looking for something. Obviously, you see our scale on the y-axis is very congested there, whereas we're just going up by ones on the x-coordinate. It looks like we're going up by 15s on the y-axis there. So I see that it looks like it's crossing right there. So that looks like 1, 45. Now here's the nice thing. F, G, and J are all proportional. They go through the origin, which means if I wanted to, I could choose any other second coordinate to subtract, right? Because remember, I'm going to need subtract. But if they're going through the origin, they're proportional. Guys, work smarter, not harder. Just make your second coordinate 0, 0. So you don't really even have to do anything. Watch. Y, 45 minus your other y, 0, over x, 1, over your other x. Well, 45 minus 0 over 1 minus 0 is just 45 over 1, which is just 45, which actually happens to be what I'm looking for. So I'm pretty sure that's going to be my answer. But you notice I didn't even really need to do this. I could have just taken my y over my x as my slope because I'm using the other set of xy coordinates. I'm using the origin. So we're working smarter, not harder. Let's look at g right here. So this is going to be 1 over 1 and 15. So this is going to be, remember, our y over x. So we could just do right there 15 over 1, since we're using the origin as our second set. So it's close, but it's not nearly steep enough. H, we can't even do anything with. Look, there is no change in our y. It's straight. So there is no slope. What do we have here? Oh, this is way too steep. This is 160. So that's going to be 60 over 1, or just 60. And that's too steep, right? I don't need 15. I don't need 60. What I'm looking for is my F, and that is my answer.